Welcome back to the Nebula Engineering channel. Today we will explore steel, a symbol of strength and resilience, which has been the backbone of civilizations for over 4,000 years. From ancient Anatolia and Sri Lanka, steel has played a vital role in laying the foundation for human development. The journey of steel, from raw iron to becoming the backbone of modern skyscrapers, is a testament to human creativity and ingenuity. Not only is steel essential in infrastructure, but it is also a key component in everyday items, contributing to a global industry worth billions of dollars. So how is steel produced? Join us as we explore the process and understand the crucial role steel plays in the modern world.
Preview.
The journey of steel begins with its core raw material, iron ore. This mineral, rich in iron oxide, is mined from the earth in resource-rich countries like India, South Africa, and Canada. With colors ranging from dark gray to deep purple and rusty red, iron ore plays a critical role in steel production. Equally indispensable is coal, a high-carbon fuel sourced from regions such as Eastern Europe, South America, and Indonesia. Coal provides the immense energy required to smelt the ore and create crude steel. Accompanying iron ore and coal is limestone, an essential component used to remove impurities during the steelmaking process. Limestone is abundantly available across various regions, from North Africa to Southeast Asia, ensuring a steady supply for this industrial sector. Before entering the blast furnace, iron ore undergoes a process known as beneficiation, where it is crushed into fine powder to increase its iron content and remove impurities. This marks the beginning of an extraordinary journey, transforming raw natural resources into powerful steel products that shape the modern industrial world. After the iron ore is ground into fine powder, the next stage of processing begins to maximize extraction efficiency. One of the key techniques is flotation, where the powdered iron ore is mixed with water and special chemical reagents to create a slurry. At this stage, magnetic separators play a crucial role by attracting magnetic iron particles, effectively separating them from non-magnetic waste materials. This is a pivotal step to ensure the ore achieves the highest iron content before entering steel production. Simultaneously, coal, an essential component, undergoes a process called coking to remove impurities and increase its carbon content. In coke ovens, coal is heated in the absence of air, transforming it into coke, a hard, porous, and gray fuel. This process not only purifies the coal, but also ensures optimal energy for the subsequent steelmaking stages. The steel production process begins in a blast furnace, a massive tower standing about 30 meters tall. Here, key raw materials such as iron ore, coke, and limestone are introduced. At extremely high temperatures, reaching up to 2,000 degrees Celsius, 3,600 degrees Fahrenheit, a series of chemical reactions occur. Coke, acting as both a fuel and a reducing agent, breaks down iron ore into molten iron, while limestone serves as a flux, combining with impurities to form slag, a lighter material that floats on the surface of the molten iron. Inside the furnace, the iron ore undergoes a process called deoxidation, where oxygen is removed from the iron oxide, resulting in molten iron, also known as pig iron. However, due to its high carbon content, pig iron is brittle and unsuitable for most applications. To refine it further, it is transferred to a basic oxygen furnace, BOF, or an electric arc furnace, EAF. In a BOF, pure oxygen is blown into the furnace to reduce the carbon content, producing carbon monoxide and carbon dioxide gases that escape the molten metal. Meanwhile, the EAF method recycles steel scrap using powerful electric arcs, reducing carbon and removing impurities. After reducing the carbon, alloys such as manganese, nickel, and chromium are added to achieve desired properties like strength, hardness, and corrosion resistance. This is a critical step in transforming crude steel into high-quality steel, ensuring its suitability for a wide range of modern industrial applications. The shaping process of steel begins with hot rolling, where steel passes through large rollers while still at high temperatures. This process shapes steel into forms such as sheets, bars, and wires, while also enhancing its mechanical properties like toughness and ductility. The surface of the steel is treated during this stage to remove the oxide layer, scale, formed during heating, using high-pressure water jets or scale breakers for thorough cleaning. Next, some steel products undergo cold rolling to achieve higher precision and a smoother surface finish. This process increases the hardness and wear resistance of the steel, but can make it more brittle. To address this, steel is subjected to heat treatment, where it is reheated and then slowly cooled to improve ductility and reduce hardness. Finally, protective coatings, such as galvanization, tin plating, or color coating, are applied to enhance corrosion resistance and aesthetic appeal. These steps are crucial to ensuring that steel meets the rigorous demands of modern industries. Quality control in steel production is a continuous process to ensure the product meets strict industry standards. From start to finish, steel undergoes multiple critical tests to evaluate its strength and consistency. First, tensile strength testing is performed to measure its load-bearing capacity, while hardness testing and microstructure analysis assess the quality of the steel at a detailed level. Additionally, non-destructive testing methods like ultrasound and X-ray are used to detect internal defects without damaging the product. These rigorous testing procedures ensure that steel reaches the highest quality before reaching consumers, contributing to the safety of construction projects and reinforcing the vital role of the steel industry in modern industrial applications. The steel production process concludes with the finishing stage, where products are cut to precise lengths, surface polished to achieve the desired texture, and shaped or bent for specific applications. Afterward, the steel undergoes final quality inspections to ensure it meets strict standards before being approved for shipment. Steel plants also prioritize environmental protection throughout the production process. Modern measures such as dust collection systems to reduce air pollution, wastewater treatment before discharge, and energy-efficient technologies significantly minimize greenhouse gas emissions. These advancements not only safeguard the environment, but also promote sustainable development in the steel industry. Finished steel products, from bars and sheets to coils, form the backbone of modern industry, with applications spanning construction, automotive, household appliances, and packaging. With its durability and high recyclability, steel is an indispensable material for a sustainable future. After being securely packaged and labeled with detailed tracking information, steel products are ready to be shipped worldwide, meeting the ever-growing demands of modern industries. The journey of steel marks a remarkable transformation from raw ore into the foundational material of modern society. The steel production process is a complex blend of ancient methods and cutting-edge technology. From iron reduction in blast furnaces to high-precision continuous casting and stringent quality control, steel stands as a testament to human engineering excellence. The result is a versatile, sustainable material that is indispensable in our daily lives, from monumental structures to the everyday products that surround us. Steel is not just a technological achievement, it is a symbol of sustainable development and relentless human ingenuity. Thank you for joining us on this fascinating exploration. Don't forget to hit follow so you won't miss any of our upcoming exciting videos. See you in the next episodes, where we'll uncover more incredible stories of technology and innovation.